Hello everyone, in the last video we saw how to find IGP of composite number in n factorial. So let's revise a last question. Okay, in last question we were supposed to find IGP of 10 in 39 factorial. So 10 is nothing but 2 into 5. So in 39 factorial, how many 2's are there? Total 35 number of 2's are there. And how many 5's are there? Total 8 number of 5's are there. So how many complete pairs of 2, 5 we can form? Total 8 complete pairs of 2, 5 we can form. So from this we can say that IGP of 10 in 39 factorial is how much? Is 8 factorial. So IGP of 10 in 39 factorial is 8 factorial. Now let's move to the next part. The next part is how to find number of zeros at the end of n factorial. As we saw in previous example, IGP of 10 in 39 factorial is going to be how much? 8. Now what does it mean? What does it mean? In 39 factorial, the power of 10 is 8. Okay, IGP of 10 in 39 factorial is 8, means in 39 factorial, the power of 10 is 8. So we can express 39 factorial as 10 to the power 8 into something. So from this we can say that 39 factorial ends with how many zeros? 39 factorial ends with total 8 number of zeros. Okay everyone, so now let's try to generalize this concept. Okay, thus we can say that the number of zeros at the end of n factorial is going to be how much? 10. Okay, so to find IGP of 10 factorial, what we need? We need IGP of 2 and we need IGP of 5. Now we can say that in every factorial, IGP of 2 is going to be greater than IGP of 5 because 2 comes in every alternate term and 5 comes after every 4 terms. So we can say that in any factorial, okay, take any factorial, in that factorial IGP of 2 is always going to be greater than IGP of 5. Thus IGP of 10 is going to be how much? Minimum of IGP of 2 and IGP of 5. Okay, we want to find how many complete pairs of 2 and 5 are there. Okay, for IGP of 10 we want to find how many complete pairs of 2, 5 are there. So whichever number is going to be minimum, that number is going to be our answer. So IGP of 2 in any factorial, IGP of 2 is going to be greater than IGP of 5. So minimum of IGP of 2 and IGP of 5 is always going to be IGP of 5. So from this what we can say that the number of zeros at the end of any factorial is nothing but IGP of 10. And IGP of 10 is always going to be IGP of 5. So our conclusion is the number of zeros at the end of any factorial is always going to be how much? IGP of 5 in n factorial. Okay everyone, so this is the concept here. So now let's do a question. Let's find the number of zeros at the end of 76 factorial. So our answer is nothing but IGP of 5 in 76 factorial. So let's find IGP of 5 in 76 factorial. Divide 76 by 5, the quotient is 15. Now divide 15 by 5, the quotient is 3. Divide 3 by 5, the quotient is 0. So we need to stop here. So the number of zeros at the end of 76 factorial is going to be how much? 18. Now let's find number of zeros at the end of 192 factorial. The answer is going to be IGP of 5 in 192 factorial. Let's find IGP of 5 here. That is going to be how much? 192 divided by 5. The quotient is 38. Okay. Now divide 38 by 5. The quotient is 7. Divide 7 by 5. The quotient is 1. Okay. And divide 1 by 5. The quotient is going to be 0. So we need to stop here and add all these quotients. The addition of all these quotients is going to be how much? 46. Okay everyone. After this, let's do a small exercise. Okay, under number of zeros at the end of n factorial, let's do a small exercise. What I will do is I will write factorials, then IGP of 5 and the number of zeros at the end of it. Okay, the smallest factorial is 0 factorial. Take any factorial from 0 factorial to 4 factorial. Okay, take any factorial from 0 factorial to 4 factorial. In that factorial, IGP of 5 is going to be how much? Okay everyone, so now take any factorial from 0 factorial to 4 factorial in which there is no any number which is a multiple of 5. So we can say that IGP of 5 is going to be how much? 0. Thus number of zeros at the end of that factorial is going to be 0 only. Okay, Now the next is 5 factorial to 9 factorial. Take any factorial from 5 factorial to 9 factorial. In that factorial, in the value of that factorial, how many times 5 will get multiplied? Okay, 5 will get multiplied only in 5. Okay, so 5 factorial to 9 factorial, take any factorial in which the number of 5s is going to be 1 only. So that those factorials will end with only 1 0. Take any factorial from 10 factorial to 14 factorial. In that factorial, how many times 5 will get multiplied? There are two 5s. One 5 is available in 5 and the second 5 is available in 10. So take any factorial from 10 factorial to 14 factorial. How many times 5 will come? 2 times 5 will come. So IGP of 5 is going to be 2. So that factorial will end with how many zeros? 2 zeros. After that, take any factorial from 15 factorial to 19 factorial. Take any factorial. In that factorial, how many times 5 will get multiplied? 3 times. First is in 5, second is in 10, and third is in 15. So how many 5s are there? Total 3 5s are there. So these many factorials will end with total 3 number of zeros. After that, take any factorial from 20 factorial to 24 factorial. In that factorial, how many times 5 will get multiplied? 4 times. First 5 is in 5, then in 10, then in 15, and then in 20. Total how many 5s will be there? Total 4 5s will be there. So IGP of 5 in that factorial is going to be how much? 4. So that factorial will end with how many number of zeros? That factorial will end with total 4 number of zeros. Okay everyone, now after this 25 factorial to 29 factorial, take any factorial. That factorial will end with how many zeros? Okay, in that factorial, how many times 5 will come? Okay, so the first 5 will come in 5, second 5 will be in 10, third one will be in 15, fourth one will be in 20, and in 25 there are 2 number of 5s. Okay everyone, so total how many times 5 will come? Total 6 times 5 will come. So from this we can see that take any factorial from 25 factorial to 29 factorial, that factorial will end with how many zeros? That factorial will end with 6 number of zeros. Okay everyone, so from this we can see that there is no any factorial which ends with exactly 5 zeros. Okay, from this we can say that there is no any factorial which ends with exactly 5 zeros. Now what we'll do is, let's do a question. The question is, find the difference between number of zeros at the end of 123 factorial and 127 factorial. Okay everyone, so let's do this. Find the difference between the number of zeros at the end of 123 factorial and 127 factorial. Same concept we need to use here. Okay, so let's say the number of zeros at the end of 123 factorial is x and the number of zeros at the end of 123 factorial is y. Now we need to find the value of y minus x. So basically we need to find the difference between IGP of 5 in 123 factorial and 127 factorial. For that we need to find the multiple of 5 which is included in 127 factorial but not included in 123 factorial. So now tell me which multiple of 5 is included in 127 factorial but not included in 123 factorial. That number is 125. Okay everyone, 125 is multiplied in 127 factorial but it is not multiplied in 123 factorial. So 125 is a term which is available in 127 factorial but not available in 123 factorial. So 125 will make a difference. So now we know 125 is equal to what? 5 into 5 into 5. So from this we can say that in 127 factorial there are 3 extra 5s in comparison with 123 factorial. So from this we can see that IGP of 5 in 127 factorial is 3 more than IGP of 5 in 123 factorial. So we can say that 127 factorial ends with 3 more zeros than that of 123 factorial. Okay everyone. Okay everyone. So now let's have a look at one more question. The question is, find smallest factorial which ends with exactly 13 zeros. Over here we want to find out the factorial which ends with exactly 13 zeros. Means number of zeros at the end of n factorial has to be 13. Means IGP of 5 in n factorial has to be 13. Means we want 13 number of 5s in n factorial. Now we know that multiple of 5 comes after every 4 numbers. Okay, we know that multiple of 5 comes after every 4 numbers. Take any two multiple of 5s. Let's take 10 and 15. How many numbers are there in between 10 and 15? There are 4 numbers in between 10 and 15. Okay, so from this we can see that multiple of 5 comes after every 4 numbers. So for that, what we need to do is we need to multiply 13 by 4. Okay everyone, multiple of 5 comes after every 4 numbers. So for that, what we need to do is multiply 13 by 4. We will get 52. Okay, it doesn't mean 52 factorial is our answer. Okay, our answer is going to be nearby 52 factorial. Okay everyone, it doesn't mean 52 factorial is our final answer. Our answer is going to be 52 factorial. Okay, so now let's check IGP of 5 in 52 factorial. Okay, let's check IGP of 5 in 52 factorial. If we divide 52 by 5, the quotient is 10. If we divide 10 by 5, the quotient is 2, and if we divide 2 by 5, the quotient is how much? 0. So we need to stop here and add all these quotients. So we can say that the IGP of 5 in 52 factorial is going to be how much? 12. But we want IGP of 5 to be 13. So we need to go to the next factorial, which includes extra multiple of 5. So after 52 factorial, we need to check 53 factorial. No, not 53 factorial. We need to check 55 factorial. Okay. So in 55 factorial, the IGP of 5 is going to be how much? Divide 55 by 5, the quotient is 11, and divide 11 by 5, the quotient is equal to 2. Divide 2 by 5, the quotient is equal to 0. So sum of all these quotients is equal to how much? 13. So from this we can say that 55 factorial is the smallest factorial which ends with exactly 13 zeros. Okay everyone. Now let's have a look at one more question. How many factorial ends with exactly 37 zeros? Means the number of zeros at the end of n factorial we want to be 37. Means IGP of 5 in n factorial has to be 37. Means we need 37 number of 5s in n factorial. Multiple of 5 comes after every 4 numbers. So for that, what we need to do? We need to do 37 into 4. Okay, multiple of 5 comes after every 4 numbers. We need 37 number of 5s. So multiply 37 by 4. Okay, it is equal to how much? 148. It doesn't mean our answer is 148 factorial. Our answer is going to be nearby 148 factorial. Okay everyone. So let's check in 148 factorial, IGP of 5 is how much? If we divide 148 by 5, the quotient is 29. If we divide 29 by 5, the quotient is 5. If we divide 5 by 5, the quotient is 1. So sum of all these quotients is how much? 35. Okay everyone. But we want number of zeros. We want IGP of 5 to be 37. So we need 2 extra 5s. So after 148 factorial, we need to check 150 factorial. Okay. Because in 150 factorial, the extra 5s will get multiplied. So let's check 150 factorial. In 150 factorial, IGP of 5 is going to be how much? Divide 150 by 5, the quotient is 30. Divide 30 by 5, the quotient is 6. And divide 6 by 5, the quotient is going to be 1. And sum of all these quotients is going to be 37. So 150 factorial is the smallest factorial which ends with exactly 37 zeros. Okay everyone. After that, after 150 factorial, which factorial is having additional multiple of 5s? That is 155 factorial. So in 155 factorial, the IGP of 5 will increase now. Okay. We want IGP of 5 to be 37 only. We want number of zeros at the end of n factorial to be 37 only. Means we want IGP of 5 to be 37 only, not more than 37. Okay. In 155 factorial, the IGP of 5 will be more than 37. Okay. So 150 factorial to 154 factorial, take any factorial. Okay. 150 factorial to 154 factorial, take any factorial. In that factorial, IGP of 5 is going to be 37 only. Means 150 factorial to 154 factorial, these are 5 factorials which ends with exactly 37 zeros. Okay everyone. Now let's do one more question. The next question is find how many factorials ends with exactly 30 zeros. Over here, number of zeros at the end of n factorial we need to be 30. Means IGP of 5 in n factorial has to be 30. Means we need 30 number of 5s. We know multiple of 5 comes after every 4 numbers. That is why we need to multiply 30 by 4. 30 into 4 is equal to 120. It doesn't mean our answer is 120 factorial. Our answer is nearby 120 factorial. So now let's check IGP of 5 in 120 factorial. If we divide 120 by 5, the quotient is 24. If we divide 24 by 5, the quotient is 4. If we divide 4 by 5, the quotient is 0. So we need to stop here. Add all these quotients. The sum of all these quotients is going to be how much? 28. So IGP of 5 in 120 factorial is 28. We want that IGP of 5 to be 30. So we need to check the multiple of 5. We need to check the next factorial which is having extra multiple of 5. So after 120 factorial, we need to check 125 factorial. In 125 factorial, IGP of 5 is how much? Let's find it out. If we divide 125 by 5, the quotient is 25. If we divide 25 by 5, the quotient is 5. And if we divide 5 by 5, the quotient is 1. So we need to stop here. After this, quotient will be 0. And sum of all these quotients is going to be how much? 31. So from this, we can see that 120 factorial to 124 factorial. Take any factorial from 120 to 124 factorial in which IGP of 5 is going to be 28. And after that, 125 factorial is having IGP of 5 as 31. So from this, we can see that there is no any factorial which is having IGP of 5 as 30. Means there is no any factorial which is going to end with exactly 30 zeros. So our answer is going to be 0. So there are 0 number of factorials which ends with exactly 30 zeros. Now let's do the next question. Find smallest factorial having IGP of 7 as 18. Over here, IGP of 7 in n factorial is going to be 18. Means we need 18 number of 7s in n factorial. We know that multiple of 7 comes after every 6 numbers. So we need to multiply 18 by 6. That is equal to how much? 108. It doesn't mean our answer is 108 factorial. Our answer is nearby 108 factorial. Okay everyone. So in 108 factorial, let's check IGP of 7. If we divide 108 by 7, the quotient is going to be 15. If we divide 15 by 7, the quotient is going to be 2. If we divide 2 by 7, the quotient is going to be 0. Add all these quotients. This addition is how much? 17. So from this, we can see that in 108 factorial, the IGP of 7 is how much? 17. But we want IGP of 7 to be 18. Okay. So now, which factorial is there after 108 factorial in which extra 7 is multiplied? Okay everyone. So for that, we want multiple of 7 which is after 108. Okay. After 108, which number is multiple of 7? That is 112. After 108, which number is multiple of 7? That is 112. So 16 into 7 is 112. Okay. So after 108 factorial, we need to check 112 factorial. If we check 112 factorial, let's find IGP of 7 here. Divide 112 by 7, the quotient is 16. Divide 16 by 7, the quotient is 2. Divide 2 by 7, the quotient is 0. So we need to stop here. And sum of all these quotients is how much? 18. So from this, we can see that 112 factorial is the smallest factorial. 112 factorial is the smallest factorial having IGP of 7 as 18. Okay. Now let's do the next question. The next question is find smallest factorial which is completely divisible by 5 to the power 32 and 7 into 7 to the power 26. The question is find smallest factorial which is completely divisible by 5 to the power 32 into 7 to the power 26. So over here we need a factorial having IGP of 5 at least 32 and IGP of 7 as at least 26. Okay everyone, we need to cancel out all the 35 5s. We need to cancel out all the 26 7s. So we need a factorial having IGP of 5 as at least 32 and IGP of 7 as at least 26. So first of all, let's find the smallest factorial having IGP of 5 as 32. Okay everyone, let's find the smallest factorial having IGP of 5 as 32. So IGP of 5 in n factorial is 32. Multiple of 5 comes after every 4 numbers. So 32 into 4 is 128. So our answer is nearby 128 factorial. So if you check 125 factorial, okay, If you check 125 factorial, the IGP of 5 in it is going to be how much? 25 plus 5 plus 1, that is equal to how much? 31. Divide 125 by 5, quotient is 25. Divide 25 by 5, quotient is 5. And divide 5 by 5, the quotient is 1. So sum of all these quotients is 31, but we want 32. So we need to check 130 factorial here. Okay, if we check 130 factorial, how much is their IGP of 5? Divide 130 by 5, the quotient is 26. Divide 26 by 5, the quotient is 5. And divide 5 by 5, the quotient is 1. Sum of all these quotients is how much? 32. So 130 factorial is the smallest factorial which is having IGP of 5 as 32. Okay everyone. Now let's find the smallest factorial having IGP of 7 as 26. So we want IGP of 7 as 26. 7 multiple of 7 comes after every 6 numbers, so that is why we need to multiply 26 by 6. So 26 into 6 is how much? 156. So our answer is going to be nearby 126 factorial. Sorry, 156 factorial. So let's check IGP of 7 156 factorial. Okay, divide 156 by 7, the quotient is 22. Divide 22 by 7, the quotient is 3. Divide 3 by 7, the quotient is 0. So we need to add all these quotients. The sum of all these quotients is 25. So 156 factorial is having IGP of 7 as 25, but we want IGP of 7 as 26. So take a number. Which number is a multiple of 7 after 156? Okay, after 156 the multiple of 7 is 161. So now we need to check 161 factorial. So in 161 factorial, let's find the IGP of 7. Divide 161 by 7, the quotient is 23. And divide 23 by 7, the quotient is 3. Divide 3 by 7, the quotient is 0. So we need to stop here and add all these quotients. The sum of all these quotients is going to be 26. Thus we can say that 161 factorial, okay, 161 factorial is the smallest factorial having IGP of 7 as a 26. Okay everyone. So how to decide our answer now? We want a factorial. Look here. We want a factorial having IGP of 5 as at least 32 and at least 26. Okay everyone. So 130 factorial is the smallest factorial having IGP of 5 as 32. Means the every factorial which is more than or equal to 130 factorial will satisfy this condition, at least 32 5s. Okay, and we want at least 26 7s. Okay everyone, we want at least 26 7s. So 161 factorial and the every factorial which is more than 161 factorial satisfies this condition. So from this we can say that 161 is the smallest factorial which is having IGP of 5 as at least 32 and IGP of 7 as at least 26. So 161 factorial is the smallest factorial which satisfies both conditions. So our answer is 161 factorial.